Hello everyone and welcome. Today, inshallah, we will see some Hysys integration with AI. Hopefully this will be interesting. All what we're going to see, this is personal initiative. It's not related to any kind of features or any products. This is just my own work. So today we will see some things in Hysys, how to connect with Hysys, how to build a small flow sheet using AI. And at the end, AI will do some optimization also for me. So in order to start, let me go here and uh, open Hysys case that I have. So I will try here. So I'm using Telegram here just to show you that this can be done anywhere. You can communicate with your Hysys case. And I want you, okay, so let me write that in a good way. Okay, so he went to some predefined folders. He tried to find this case. He couldn't find it, but hopefully he will be able to do this now. I was saying that we can communicate or chat with our model using any kind of tools, for example, here Telegram. But the idea that you can think about speaking to your model, you can just send a voice message and then the model can reply. Okay, so this could be a good thing. As you can see here, my Hysys is here now. So let's try to make this a little bit bigger. Okay. So now let me show you something. For example, this section line here, okay, and it has this values. So we can ask him. So we can say, for example, what is the mass flow rate of K100 section line? Okay. So hopefully you will be able to get this number. And as you can see, it's the same number that we have here. Okay. So this is good. He can read and he can write. So to test this, let's say change it to 200,000, for example. And it's not writing. He is a little bit smart because now he will go there and he will find that this number here, this value, it's calculated by Hysys. So he will tell me that he cannot change this and he will give me some options. The first one here is that he identifies that this is related to the molar flow. So he is saying that he can change the molar flow until he can achieve this. Okay, so I'll go with this option. And the second option is a little bit straightforward. He will remove the molar flow specifications and he can change the mass flow. And here, as you can see, he was able to change this to achieve the 200 that we have asked him to do. So this is the first one, is the connection to the Hysys case, which looks good and smart also. Okay, so now let me try to find something here. I did it before, not this one. Let's go with building first to show you this. Okay, so I will ask him to add a separator, and there will be a compressor on the overhead and bump on the bottom lines. Okay, so let's see if he can build this in a good way or not. Okay, so now he is trying to figure out what is required. I believe he will start by adding the feed streams, and he will start by doing the connections and the other equipment. So as you can see here in the background, he is adding a separator feed stream, and he should start adding the other equipment now. Of course, all of that is happening over the Olama server for the LLM, which takes some time. If this was on my machine, this could have been faster. Okay, good. So as you can see, he added the separator. He was able to add the top and bottom connections. Now something also happened here. He added the, and we are waiting for the last piece of equipment, which is the bomb. But the small, okay, actually it's a solved system. So he was able to identify the requirements of each stream and each equipment, and he was able to solve the system, which is a good thing, a little bit smart. Okay, so we have seen the connections, we have seen the building. So let me show you something interesting also that can be done. So we can do optimization. We can ask him to do optimization. So let me take this one here and say here that surrounds the compressor efficiency. But let's say because we have two compressors now, so I will identify this compressor here, K100. Okay, efficiency by changing the suction stream molar flow, because we know that mass flow is not changeable. So we can do this now. And I will send that. So I'm telling him, please change this efficiency. So if we go here for this compressor, let me show you this here in the plot curve. Okay, it's plotting, yes, here. This is too big. Okay, so let's make this. So as you can see, he is changing the molar flow to get the best efficiency while he is maintaining the constraints, okay? So we will see what will be the results of that. But now it seems that he completed this. So I have specified two constraints, one for the power and one for the discharge pressures. So let's see. For the discharge pressure, it seems that he hit the constraint here, okay? And this is why he stopped. So I think we should see the efficiency here, which is this one, okay? And on the curve, we stopped here. So now he was able to do this with himself, okay? But I want to show you um, another thing. If we relax it, these constraints, he should be able to achieve this point here. So let me take this again, okay? And I'll set it here. But now we can allow higher power, okay? And we can also allow for less. So hopefully now he will try to increase the efficiency, and there will be no constraints, okay? So he should be able to hit um, this value here. As you can see, he is bounding until he will reach the optimum point. Okay, so it seems that he is good now around what we need exactly. I think because I have very tight tolerance, he will spend some time on that. But again, he was able to achieve this, and he is telling me that, okay, this efficiency was achieved, and be happy with that. So hopefully this was interesting as promised, and thank you.